9 over 15. 9 over 15 is like, okay. Yeah, I'm like, I haven't, my active really kind of
Most exciting part of the class. Okay. All right, guys. Sorry, in the interest of time, we're going to kind of start to go over these together. Okay. In about 10 minutes, we'll head out on a little field trip. We're going barely anywhere. I'm sorry, so I shouldn't call it a field trip. So just you can stay where you are if you want to, but we're going to go over this. I'm going to be recording this, so I'll put it up on the YouTubes later. So I had a vote. I was asking somebody what they thought the hardest problem was, and they said this one because they forgot how fractional powers work. I don't blame you. Fractional powers are trippy. It's really quick to forget what the hell they do, or maybe some of us never saw them. So we'll talk about that. Any other votes for like freakiest, hardest problem on this? Yeah, F is just straight brute force distributed. Yeah, exactly. It's like an extended foil, right? Okay. What's this first problem all about? What's the main idea behind that first problem? PEMDAS, kick ass. And what does PEMDAS stand for? Parentheses, exponent. What's the saying? Please excuse my dumbass son. Or dear aunt son. One class, this was the class said this to me. They said, please excuse my deficient algebra skills. I'm like, all right, whatever works for you. So you got dumbass son, dear aunt Sally, whatever. Real quick. I have seen instructors who need to just stop being instructors, actually teaching that multiplication becomes before division. That is so much bullshit. We could have called it this. Which one is easier to say? Yeah, if you say this, you sound drunk, and then you have to walk the line, and who knows? You with me? Slow on this, you're like, what? This is PEMDAS. This is PEMDAS. Multiplication division. I'm going to blow you guys' mind. There is no division. There's multiplying by the reciprocal. So of course multiplication and division are the same level. You do them as they come. Addition and subtraction, same idea. There is no subtraction. There's adding the opposite. So they're the same level. They have the same level of importance. So both of these are bullshit ways to write this. Go away. Bad. Here's the right way to write white. Here's the white way to write PEMDAS. Definitely parentheses first. Definitely exponent second. Either one of these as they come, and then either one of these as they come. So what's at the ass end of PEMDAS? Addition and subtraction. You do those last, unless they're inside parentheses. So let's take a look at this weird ass problem. What's the very first thing I should do? Inside the parentheses. And what's -1 minus 2? Oh, there they are. So I got a big mistake I get. Did anyone make this -2? No. Good. Because this is not 3 minus 5. This is 3 minus I don't know yet. You have to do all this business. So what's the last thing I'm going to do? Because what's at the ass end of PEMDAS? Addition and subtraction. So this 3 minus is just going to come for the ride. You guys see that? Now, PEMDAS is remarkably important. This is a nothing but order operations problem, but order operations is everywhere. It's like grammar. How many of you guys know more than one language? I know there's a few of you guys. When you learn a different language, very often it's the grammar that trips you up. Now, vocabulary is difficult already. And if you ever saw Finnish before, you're like, why do you guys like use every letter in your language in every word? But, so that's interesting. But yeah, when you learn a different language, a lot of times it's the grammar that throws us off. Math is a different language. What do you guys do? Jesus. All right. So PEMDAS is all about the grammar. How do you interpret what a problem is saying depends on the order you're supposed to do things in. So you guys told me this is -3. Now be really careful. There are still parentheses, but inside of them is done. So now we're on the next level. What do I do next? Exponents. Now I'm going to write this wrong. What is -3 cubed? Now I have written it wrong. Does anyone see what I've done wrong? Because what is the operation right here? And if I write like this, it's I somehow made multiplication become division, become subtraction, and that's some trippy magic shit. You with me?
Yeah.
I can't change the operations that are supposed to happen. So I cube this, I still have to multiply it by that. And this is where me saying no calculator might be kind of evil, but too bad. And again, this guy's just coming for the ride. What do I do next? What is this whole chunk all about? This whole chunk involves what? Multiplying, dividing. So I do it as it comes. So if you made this 27, that's not fair. I want this, if you look at it like I just said, order operations makes more sense. What's the only number I'm dividing by the way it's written? If I make 9 times 3, 27, now what am I dividing by? 27. That's not fair. That's not fair. Poor little number. It's supposed to only be divided by 9. You're divided by 27. That ain't fair. What the shit? So, this is what I mean by multiplication division as it comes. I have seen instructors teach multiplication for division. I'm like, you need to go away. You need to stop. It's the most basic shit. And I know most of you guys are not on Facebook. I'm barely on Facebook. Facebook is an old person thing. So maybe I should be on there. But I'll go on there sometimes and I'll see this discussion about, what's this math problem? Is it one? I'm like, oh my God, help me. It's order operations. So I have to do this chunk as it comes. What is negative 5 times negative 27? Yeah, 135. The two negatives kill each other, right?
Yeah.
Then I divide that by 9. 15. Good. Then I do 15 times 3. 45. And then I finally get 48. That's a nice meaty math problem. I love it. So this whole chunk you have to do straight across. This times this, and then divide it by 9, and then times 3, and then the last thing you finally do is the poor little 3. He's just been waiting this whole time. So everybody cool with this minus became a plus, because negative times negative is positive. Okay, maybe. Good old PEMDAS. Okay. What about this problem? What are your eyes drawn to? Good. When you have an equation or an expression, you look for parentheses because that tells you you have to do what there. What do you have to do there? Distribute. Now, how much am I distributing? What exactly is being distributed? Just the negative 2, correct? There's no foiling here. If they meant foiling, they would have had to collect a bunch of shit together. Here they just say blah, blah, minus blah, plus blah, minus twice this. Oh, so the negative 2 has to go through. Now on the way you could do this. What is negative 3y plus 10y?
7.
Yeah. And then let's bring the negative 2 through. What do I get?
Negative 2x minus 10.
Plus 10.
Careful.
10y.
Yeah, plus
Oh,
10y. And now I just slap my like terms together, right? How many x's do we end up with? 3. So 5x minus 2x is 3x. How many y's do we end up with? 17. Shabbat shalom. Kick ass. All right, one more problem and then we'll finish this up later. We'll go on our little tour. How'd the fractions go? Did anyone say the answer was 2 over negative 2? Do you guys see if somebody said the answer was 2 over negative 2? Do you guys see where that came from? That person did 3 minus 1, 4 minus 6. Right? Very, hopefully, obviously wrong. Correct? If that would have said 3/6 minus 1/6, what's 3/6 minus 1/6? 2/6. So freaking fractions, when you're adding and subtracting them, they're just like terms. If they are not like terms, I can't put them together. I have to focus on making them like terms. And that's where like denominators come, which I normally say denominator. What would the LCD be here? 12, yes, because I can multiply both of the bottoms to be 12. So multiply the first dude by 3, second dude by 2. You get 9 minus 2 over 12, which is 7 over 12. Cool. Now, if you made the denominator 24, it's not the end of the world. You didn't get the LCD. You have to reduce at the end. Okay. All right, so do me this favor. We're about to take a little tiny exhibit tour. We're going to walk past my office. We're going to go into the Math Science Center, into the CISL. So can everybody do this for me? Pack up. Start to walk this way very slowly and wait until I get in front of you. Okay. Here we go. Oh, thank you.
We're done.